Alright, so back to the big uglies, finding the complex solutions when you're dealing with quadratics or cubics, etc. So here's a quadratic. We're going to show you one way to solve it is simple algebra. So you could just subtract 32 on each side, divide by 2, take the square root, and then we now know that you can take a square root of a negative number. You get the imaginary root, so plus or minus 4i.
Yep, don't forget that plus or minus because it's a square root. You're taking 2 of them. It's an x squared, so you got 2 solutions there that you should have. All right.
2 solutions.
Your other option, since it's set up to equal to 0, up on the top right, we got that quadratic formula. A is 2, B is 0, C is 32. Plug it in, figure it out that way too. So
yeah, and think back to the rules for quadratics. How do we know it's a quadratic? Here it is. It's a second degree polynomial.
All right, now we got one of these big ugly ones. So the first thing that we did with this, took that equation, put in the y equals, made y2 equal to 0. All right, you can, after that, sorry, you put it, you go to your table, or, you know, and once you hit your table, you're going to look for when y is equal to 0. Your other option is graph it, and then do second trace intersect, which is option 5. Get x equals -2. And then what do we do with that -2?
Well, we go ahead and set it up for synthetic division. Right now we've got a cubic, and remember what synthetic division does is it brings it down from a cubic to a quadratic, something we can solve with the trusty quadratic formula. So here's our coefficients from the original cubic.
The 8, the 22, the 17, and the 10. There they are.
And we're using our -2. It is a 0 of this function right here. So we go ahead.
Step, bring down that 8. Then we multiply it by -2.
Add.
Yep, combine them. Keep going, keep going, keep going. So,
okay.
Right. That was our review. So if you're, you know, sort of fuzzy on that, bring some questions to us. All right. After this, it equals 0, so we did it right. And we know our A is 8, B is 6, and C is 5.
Okay, and you can go ahead and just plug those in right to your quadratic formula. Again, this is review, so we're not going to really break it down for you. Just come with questions if you have them, and then you go ahead and simplify. Now what we're going to do here, which is a little bit different than what we've done, is to actually completely simplify when you're left with imaginary roots. Before we told you, you know, just leave it alone. We've now got the skills to go ahead and extract those imaginary or complex roots. So like we've been doing for the last week, we can break down that -124 into -1 times 4 times 31.
All right, and the -1, we can say the square root of -1 becomes your I. The square root of the 4 becomes 2. All right, and we get this square root of 31. Can't do anything with it. It's actually prime. Can't break it down at all. So we get to that point. Now, there's one more thing. If you look, we got a -6 out in front. We got a 16 on the bottom, and we got the 2 up by the I. All right, so all those have a greatest common factor of 2, so we can divide the 2 out of every single part of there.
Divide them all by 2, and that's what you get. Half of -6, half of 2 is 1, and half of 16 is 8.
And you don't divide it into the 31. It's underneath. Think of the I and the square root of 31 as being like x and y. If you had -6 plus 2x over 16, you don't change the x stays the same. So it's the same deal. Don't touch what's underneath, don't touch the I. Just look at that coefficient there. So,
hey, taking some of the skills we already had and applying them to something new is the big idea here in complex roots. Questions, bring them to class.
All right, signing off.
See ya.